Welcome to the session. Greeting of the day. In today's class, we are going to talk about the various types of PLC programming. What are the ladder programming? How we are going to do? In the previous class, we have done about the various setups of various AND functions, logic gates we have seen in the last class. Such as AND gate, AND gate, OR gate, AND or not OR gate. So such cases we have seen. Right. So see, further little bit we extend about going for the latching connections. Latching. So another word I am adding, it is a latching process. The latching to hold a coil energized the input which energizes its CS. Self-maintaining the circuit. This word is very wonderful word. Self-maintaining the circuit. Maintaining the state, whether it may be on state or it may be off state, until another input is received. That is called as latch. How I am doing? You see, here I have input 1, input 2 and output. Now I am switching on the input 1. What happens? From the power rail, the connection is went and it is disconnected. And it is on. The motor is on, and I am latching. The word I am using here. I am latching this output in terms of contact. So when the motor is on, this word output I have typed here also. So this will gives engagement in the second rail, second rung to this one. Therefore, I am latching this output name here. When this is on, this should on. Now what happens? This is in parallel OR function. So this again connection is in latch and it goes here. Now what I am doing, I am removing the input 1. What happens? You see, I am removing the input 1. I am removing the input 1. I am removing the input 1 even though the connections are moving from here. The connections are moving from here and it is moving to the motor. Motor is running. Because of this latching operations, output I have taken and output I have named here, and it is moves until the next state, until another input is received. What is another input? Another input is input 2. When I am giving the second input to disconnect this one, when I am giving the second input to disconnect this one, then only the power circuit won't go there. When the input circuit is disconnected there, what happens? There is no chance. There is no chance here. There is a simple sketch here. There is no chance. It is plain. So it is not connected. So if it is not connected, what happens there? The disconnection will happen, and therefore the circuits are all not connected. So motor won't run. Motor won't run. So this is how it will stop. So this is about latching. So what I have did here, I have named here. This is a start. You see, this is a start. I have connected. Circuit is moving from here to here. It is moving. Circuit is moving here and is moving and is connected. Now it is also latched here. So when the motor is on, it is also started. Therefore it goes even though I am disconnecting this. Power is not went. Here the power is not there. How the power goes then? The power is going through this way. Power is going through this way. It goes like this. Power is not there. This connection is disconnected. This path is not there. So here this path is not there. Now the secondary input I am giving to stop this connection. So this is a start and it is latched and it is working. Now I am giving the stop connection. How I am doing? I am disconnecting this. The switch is activated. When the switch is activated, the opposite function will happen there. It is already in run. So it is going to off position. So what happens when it is activated? It is going to disconnect. It is going to disconnect. If it is disconnected, then obviously the motor switches will on. will off. So it is going to disconnect here. So it is disconnected. So obviously these connections are not there. So likewise we can able to understand these connections. Right? So this is about the latching. So output is given as a contact with respect to logic function. So we have used the or functions, either this one or this one. We have completed the latching with respect to or logic functions with input contact. Output is released only when input 2 is this one. Input 2 is this one. Input 2 is energized, switched on. Running the motor, example, running a motor latched with the start and stop of a normally closed functions. So this is about the various connections. In the same latching process, now I am giving multiple inputs, the condition I am telling. The multiple inputs have been given to activate one output. You see, so many inputs for a single output I have taken. For example, barrier gates. If so many inputs of any multiple cars are coming, the gate should open. That is one output. So how I am taking? Input 1 has been detected. Input 1 has been detected, and therefore it may open or it may arm. Like that we consider. If not, input 2 has been coming. These two are in R functions, and input 2 is coming at the time also. The gate can be opened. So such this. Let us consider input 3. Input 1 and 2 we have taken here, and I have taken input 3 now. If multiple inputs we have to give in such a way, the output will on. So here multiple inputs here may be activated 1, or otherwise we have given 2 to activate. Now multiple inputs I am giving. Input 3 I have to give, and also input 4 I have to give in such a way this output 2 will activate it. That means multiple inputs are given to activate one output. So that's a very gate we have taken as an example. Now this I am connecting internal relay. I am connecting this internal relay, that this output 1 I have taken as a make contact here. When this output 1 has been activated, this activation will again activate this third rung relay coil 1. IR1 I have mentioned is IR1. The same IR1 I have taken multiple connections from there to here, and I am connecting here. When this IR1 is activated by input 1, simultaneously this IR1 will activate here also. This run 1 will activate run 3, and therefore this IR1 will give the output in terms of output 1. See, output 1 we have taken here. It may be through this run 1, or otherwise maybe through this run 2. So run 1 operated through OR functions. Here this is operated through OR functions, and this we are operated through AND functions. This is operated through AND functions, and therefore this output may come either by this relay coil, internal relay coil 1, or otherwise internal relay coil 2. This internal relay coil 1, or otherwise internal relay coil 2. This one. This we have connected in the OR connection. So this multiple inputs can given to activate one output, or finally one output has been taken. So this is about multiple input, one output. Now I have taken here about multiple outputs. Multiple outputs I have to do with respect to single input activities. Single input activities. It means so many CNC machines we are, such examples I have taken. See, I have started now. And this is starting activated with respect to internal relay coil 1. This activates this internal relay coil 1. After activating internal relay coil 1, it is reconnected here. Again it is latched. And therefore this internal relay coil will activate this also. And let us consider the start is a push button. After after starting, it will disconnect. Even if it is disconnected, what happens? You see, even if it is disconnected, we are getting a connection through this point. It is moving. Now, at the same time of internal relay 1 activating the latching, it also activates the second run. The second run also it activated, and therefore we are getting one output. That is, I named as a output 1. Here it is activated. And now, this input I am giving the second input. I am giving for output 2 I want to do now. Output 2 has been, when the input has been given here, and we know already input relay coil 1 has latched here, and input relay coil 1 is keep on running. At the same time, it activates here. This is ready. This point is ready now. But there is no power supply come from the power rail. There is no power supply coming from the power rail. From the power rail, the power should come. So it is waiting. Now, when the output is activated, after that, I am by myself, I am activating the input for 2. The switch is pressed, switch is activated. Now, the power from the power rail in this first and second run, third run, the power is keep on going to activate the output 2. You activated output 1 and activated output 2. What happens? This output 2 will able to connect to the internal relay. See, internal relay. When this internal relay is connected, it is activating the run 3 internal relay 1 and also internal relay on the 1, 2, 3, 4, 1, 2, 3. Fourth run, it is on the fourth run internal relay, this also it has been activated. Now, when input has been given by switch, input has been given for output 3, what happens? Now the power goes from here to here, it can able to connect and starts the output. So what I have done, multiple outputs on a single input activities. I have just started here. A push button has been started over. Other things are all other outputs, output 1, output 2, output 3 are activating with respect to this relay coil IR1. So here it is, I have latched also. So this connection we can able to do multiple outputs. Now you see some other latching process also we should discuss. So in such a way here I want to reset the action. This action to be resetted. Let us, for example, we take any timer is there, any counter is there. I want to give a time of 15 minutes of time. Then it should again the same process to be repeated. So I want to reset the program and we start from the starting. In the 15 minutes of time, one process has to be completed. A biscuit company or biscuit product to be manufactured in 15 minutes of time, and the second refilling and packaging of the biscuits to be done again from the starting point. Every 15 minutes the same program will run for packing of the one product. Again it runs. Likewise, some examples, we have to restart the program. What I am doing now here, so for unlatching the outputs, resetting, for what I am doing, input 1 has been started. You see, input 1 I am starting here and given the input. And now this input activated keep on travel, and here internal relay is already, it's not activated, I have not touched it, but it has been inactive. I have not, internal relay has not, I have pressed or not activated, I have not done any at nil position. At nil position, it is already normally closed state. When I am pressing, it is going to deactivate. So I am not disturbing that. So it is already in closed state and it can able to pass through the supply, and here I am activating the output 1. So this output I have latched again. So here I have done the latching. There I have done the latching process, and therefore this output will able to latch here. This output I have taken as an input. It activating this output 1, activating the latching process, and this is going again. And even though this push button is not there, the power sources will go through this way. The power sources will go through this way, and it can able to run the setup. Now, I'm giving specific like input 1, I'm giving the input 2 now. When the input 2 is there, it is going to press or activate the relay coil 1. What is relay coil? This relay coil I have connected in a normally closed position at a nil position. From the nil position I am going to activate. When it is activated, here also it is activated. How it is activated? It is activated from the 0th position to 1 position. Otherwise it is already in the 1 position, it is going to be 0 position. Now what happens? When it is pressed, it is going to activate now. How it activates? It is going to activate in this way. So this process of normally closed condition is going to deactivate now. It is going to deactivate now. So it is deactivated. So what happens? There is no power supply. There is no power supply here. There is no power supply here to the output 1. So it is disconnected. So it is as usual, it can able to disconnect. So that is how this happens. So we are removing or disconnecting or relatching, reinitiating the process or terminating the process can be done resetting. So if after resetting it is normal condition. It is not disconnected or it is coming to the normal position, and now again I want to start the program. Again I want to start the program like this and it will run. So this is resetting the latching, some methodology we can able to utilize. Some similar patterns. Now battery backup, I'm replacing the term resetting to the running term of battery backup. It's a latching process only. See, the output is controlled. Output is controlled by internal relay, which remains energized even after the power failure. It means nothing but a push button. Here we have removed, but even though it is that is called as latching. I am calling as a battery backup. It means that it is going to take a relay coil. See, now I am giving input 1 first. A press button has been done, push button has been pressed, and now internal relay coil has been activated. Internal relay coil will have activated, and the power supply has been went. After the power supply has been went, when the internal relay coil 1 is activated, it is also activates the below internal coil 1. See, IR1, this activated. Therefore, the power source goes from this power rail to the internal relay coil 1. What happens now? Now this internal relay coil also activates here in the second run. It activates here, and therefore we are getting the output 1. This is now it is latching. Now it is a latching process done. Now let us consider this is power cut happened there in the input 1. This one is the connected point. I am disconnecting this. When it is disconnected, what happens? When this is disconnected, even though it is disconnected, the power goes through internal relay coil, and then internal relay coil through here we are getting the powers. We are getting power and it can able to run. So simple, it's a latching process. I am using some other words like a battery backup. So from the example. Next I want to disconnect this entire setup. I want to run one machine, and I am creating the connection of main contact I am going to disconnect. When the run 1 is completed, the remaining run all should be terminated. I am naming this as a master control. To control the large number of outputs, output 1, output 2, output 3, to turn on or off as a whole selection, as a all selection. What we have did through only disconnection, we have did the latching process. And terminated this one, terminated separately this, like this we have did. Now I am doing a latching or terminating the whole multiple outputs I am terminating. How I am doing? I am having a master control in the power rail itself. I am having the master control in the power rail. See, here the power rail is there, here the power rail. I am going to disconnect here. How I am doing? You see, input 1. When the input 1 is connected, when the input 1 is connected, the master control relay is going to activate. So we are getting the power from the master line, it means power line, and it is going to connect. Now, what happens? And MC1, this is running, now it is running. Master relay coil is running. Now what happens? Input 2 I am giving processing. Input 2 is processed and output runs. Input 3 is processed and output 2 runs. And then it activates this master control relay. When this master control relay is activated, automatically this activating disconnects this master control relay coil here. And it is going to disconnect. So when this is connected, it is going to connect first, and therefore the power comes, and when at last it is disconnected, it is going to disconnect again. At the first stage, when the first rung is activated, here this master control MC1 is going to activate this point. It is normally open condition. When here MC1 is activated through the rung 1, this MC1 is going to start making contact here. Contact is made, and throughout the power rail, power comes. After power coming, I am pressing input 2, pressing input 3, likewise. We are doing the main laboratory equipment's main switch is there. I am considering this is a master control switch. That master control switch is on, then only we can able to on the fans, or on the machine setups, lights, maybe computers, likewise. When the main switch is disconnected, this all fans and lights, the entire laboratory setups will not work. Maybe switch MCV will tell, master control switch at the outside. So likewise, when this all switches are again, it means when the complete process is done, I keep the last MC master relay coil 1, this is going to disconnect here. When it is disconnected, what happens? There is no power rail code coming to the downward all rungs. So this is about master control. And I want the jumping reactions also, one after the other, from the run 1 to the last run. Likewise, I want to jump the program. To perform a set of instructions, if one condition is satisfied, if not, do some other set of instructions. If someone's condition is satisfied, I want to jump from one to another. For count is 10, if the count is 10 is reached, I want to go to the end of the process. If the count is 8, I want to continue the process. If the count is 7, I want to continue the process. If the count is 10, we are loading some machine parts or toys in the lorry. When the count is 10, the lorry door should close. Likewise, I am planned. When the count is 8, it will keep on counting the next process. If the count is 10, it should stop. The door should close. Likewise, we can able to jump from one rung to the another rung. So input 1, the count. Maybe input 1 I have given as a 1 input or 2 input or 3 input. How I have given. And it is connected. When input 1 is received, from here, this jump is activated there. The jump here connected to this jump. Jump activated the jump end rung. So this process will be disconnected. If not, while the program jump is not activated, input 1 is not given. Some other input 2 is given here. Some other process will, the trolley will move, the toys will be operated inside. So here it is operated. Input 3, toys again operated to the load condition. Now the lorry is full. When the lorry is full, after the 10 assembling points, we have one sensor at the end. So this sensor activated to this input 1, and therefore we understand that the input 1 is done, and therefore from there it jump to the end rung. So rung 1 to, I am going to the rung 4. Likewise, we can able to use the jump functions. So the summary. In the PLC, we have talked about this types of ladder diagrams, ladder programs. On that we have seen about logic gates of AND, OR and NOT functions we have seen. Accordingly, some this NAND and NOR gates also we have done. And after that, in the out of logic gates, we have seen the latching. And after the latching, we have seen the timers and also the counters also. The remaining part we have to continue some programs, otherwise the remaining part we have to see. The remaining part of the subject we'll see you in the next session. Thank you.